Hello. 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 Can anyone reply? Hello.
यस सर।
हाँ, आवाज आ रही ना तुम्हें?
जी सर।
हाँ, जिन्हें 10 मिनट्स के बाद अटेंडेंस ले, स्क्रीनशॉट ले, ठीक है ना?
ओके सर। ओके सर।
Okay, we can start. Uh, any girls student, please can you reply so that I can take your classes.
Yes, sir.
Okay. See here, I'm going to define the fourth unit and how it is connected to the fifth unit that we can discuss one by one. First of all, I am discussing. Already we have done this one, but if you are going to the revision part, then only you can understand today's. It means first of all, I will discuss what is Cauchy's theorem, then how it is converted to Cauchy's integral formula, and then how it is converted to Cauchy's residue theorem. So we can start. Cauchy's theorem. Sometimes in exam for 2 marks, they may ask you the statement also. Cauchy's theorem. Okay, Cauchy's theorem is different. Cauchy's integral formula is different. Now see what is the statement. I hope everything is good. All the student is listening the class carefully. Okay, now let f of z be a analytic function within, within and on the closed curve C. I'm using the word closed curve C. Then integral over C f of z dz is equal to 0. So in a simple way, we see here, this is your circle we take. This is a closed curve C I am taking. Now look at this. This is a closed curve C. Closed curve C. Okay. And here f of z is analytic function in every point within the C and on the boundaries of C. We don't get such a point where the function is not analytic. Every point function is analytic. So when we are taking the integration of the f of z over this C, the answer should be 0. This is the Cauchy's theorem.
I realize कि ताल्लुक में सिवाय अजियत और नुकसान के तुम्हें कुछ भी नहीं मिलता।
ये कुलसुम
जिस इंसान को तुम्हारे अंदर की गहराई से खाना खाने आता हो, कान को अपने किनारों पर खड़े होने की भी इजाजत मत दो। तुम हमेशा खुद होने से डरते हो। हाँ, तुम खुद खो गए हो, किसी ने ध्यान दिया।
Now next is, what is Cauchy's integral theorem? Cauchy's integral theorem. This Cauchy's theorem, only theorem, we don't have any point. But when it is converted to Cauchy's integral, we say it is formula better. Cauchy's integral formula, we can say it is how the statement will be. Look at that. Same statement, let f of z be analytic function. Here also it is analytic. And we don't get any point. Nowhere it is not analytic. Everywhere it is analytic. But if you talk about the Cauchy's integral formula, we get 1 point here. So let me write it there. Let f of z is analytic within and on the closed curve C. Closed curve C and comma and let small a be small a is any point. Small a is any point within C. In C. Then how the formula will change? You see here, integral over C f of z by z minus a dz is equal to 2 pi I into f of z at z is equal to a. And remember this point A, whose power is 1 here, this point A is called singular point here. This point A is called singular point. So we have category of the singular points also. So I think diagram is not required. I'm not going to draw the diagram for this because the same thing. Suppose only the point here, somewhere here we will get 1 point. Here the function is particularly for this point function is not analytic. So to evaluate this f of z value under this point A, which is called a singular point, where the point function is not analytic, we are given this formula. And now this formula extension is also given. Means suppose z minus a whole power 1 is there, then this formula is applicable. If suppose, for example, z minus a is in general, I am writing here, in general. Means suppose z value is 2 is there, 3 is there, integral over C f of z by z minus a whole to the power of, we have suppose n plus 1 dz. Okay, then this can be written as 2 pi I by n factorial into d power n dz power n of f of z at z is equal to a. This is called extension. पहले Cauchy's theorem हो गया. We don't get any point. Then we have Cauchy's integral formula. We are getting a single point where the function is not analytic. Now after this one, if you connect the same question to the Cauchy's residue theorem में कैसा convert हो रहा? See, this point A we are going to call it as singular point. इसी को अपन एक और terminology में, if I am writing the same point in another terminology, here we have only 1 point where the function is not analytic. Now if it is, we have so many points are there where the function is not analytic. Now this will change. The Cauchy's integral formula will be converted to Cauchy's residue theorem. That statement I will write for the next page. So now, this is Cauchy's residue. Cauchy's residue theorem. Good statement is, look at what is the statement. Let f of z be analytic function. Analytic function. And z1, comma, z2, comma, z3, and so on. Zn are the point, where function is, I'm writing in a simple way, okay? Function is not analytic. In this particular point, function is not analytic. Then how to get the value of this f of z? Integral over c. F of z dz is equal to 2 pi I into, we have to take the residue at this point, residue at this point, residue at this point, like that. Residue at the point z1 plus residue at the point z2 plus and so on, plus residue at zn plus residue at zn. What to do here is, we have to find out residue at each and every point, each and every pole, we can say. Previously, I'm using the word singular point. I'm using the word now, it is pole. Pole is also comes under the singular point category only. Function is not analytic. Now the question arises how to find out the residue at this point. So residue at the simple pole, residue at the multiple pole. Two formulas are there. I'm writing here. Residue at simple pole. Simple pole. Very, very important. This is, you may ask this question anywhere for 2 marks, for 1 mark. The formula is limit z tends to z0. This point z0 is a point. यहाँ पर z1 के place पे I'm using that z0. The formula is limit z tend to z0, z minus z0 into f of z. So it is the formula to find the residue at simple pole. Now next is residue at pole of order m. Pole of order m. And that formula is residue pole of order m. So limit, we are denoting like this, residue at z0, तो भी यहाँ पर ऐसा denote कर सकते हैं, is equals to 1, limit z tends to z0, 1 by m minus 1 factorial d power m minus 1 by dz power m minus 1 into z minus z naught raised to the power of m into f of z. This is the formula to find out residue at the pole of order m. अच्छा आपको एक क्वेश्चन आ सकता है एग्जाम में, evaluate some integral value, and if it is not mentioned in the question paper that you have to apply residue theorem or integral formula, choice is yours. You can use it either residue theorem or integral formula, but my suggestion is always use residue theorem, which is becomes easy for you. अपन एक क्वेश्चन करेंगे, we'll do it one question, दोनों भी यूज करके मैं आपको सेम आंसर बतलाता हूँ. I'll go to the next page. Someone please reply in WhatsApp that my voice is coming clearly. Now the question is evaluate integral over C to e to the power of z by z plus 1 whole cube.
उधर से ऑर्डर
कितनी आवाज आ रही है?
उधर से चलेगा, जिधर से पूरा चलेगा क्रॉस साइड चलेगी
जी हेलो हेलो Dinesh, can you hear me?
यस सर.
आवाज आ रही है? स्क्रीन दिख रहा क्लियरली?
जी हाँ सर.
Okay, thank you. Okay, let us continue the class. See here, student, please note that in this question it is not clearly mentioned to apply residue theorem or to apply integral formula. कहीं पर भी ये मेंशन नहीं है कि आप इससे करो या इससे करो. तो योर चॉइस इज देयर, यू कैन अप्लाई कोचीज इंटीग्रल फार्मूला और कोचीज रेसिड्यू थ्योरम. मैं एक काम कर रहा हूँ, ये क्वेश्चन को मैं दोनों वे से भी करके बता रहा हूँ आपको, एंड आई एम शोइंग द सेम आंसर. फर्स्ट ऑफ ऑल आई एम गोइंग टू अप्लाई कोचीज इंटीग्रल फार्मूला. ओके, so first formula is by Cauchy's integral formula. I'm writing the formula first of all. Integral over C f of z by z minus a whole to the power of n plus 1 dz is equal to 2 pi I by n factorial into d power n by dz power n of f of z at z is equal to a. देखिए यही फॉर्मूला अपन लिखे थे, यहाँ पर भी मैं आपको पिछले पेज में भी लगा के बता देता हूँ. You can see that this formula only we have here जनरल फॉर्म में लिखे. Okay, this is the form. Let us proceed. Just compare our question. Just compare our question with the formula. So if you compare, I can say that our f of z value is 2 e to the power of z, and if you compare, our a value is -1, and our n value is 2, because n plus 1 means that is can be written as 2 plus 1. N value is 2. This information are enough. Just plug in the formula and you will get your answer. Okay, let us. Thank you, CR, for sending the attendance. Integral over C. F of z is 2e to the power of z by z minus a value is -1. Okay, better to write it like this, all to the power of n plus 1. N plus 1 means 3 can be written as 2 plus 1 dz is equal to 2 by I, no change, by n factorial. N value is 2 factorial into p power 2 by dz power 2 of f of z. F of z value is 2e power z at z is equal to a is -1. So this 2 factorial is 2 itself, these two are cancelled. So 2 should be taken, this 2 should be taken outside. Now you see 2 times derivative of this one, e power z. E power z का 2 बार derivative. E power z answer is e power z only. If you do it how many times? 2 times also we get the same answer. 100 times also we get the same answer. Here pi I is also left. Pi I, and this 2 will be outside. And 2 times derivative is e power z only. And we have to plug this one at z is equal to -1. So if z value is -1, what I am getting the answer is 2 pi I into e power -1 can be written as 1 by e. So finally our answer is 2 pi I by e. कितना आंसर आया? 2 pi I by e. Using Cauchy's integral formula, I am getting the answer is 2 pi I into 1 by e. I can show you the same question can be solved by using Cauchy's residue theorem, and again I will get the same answer. Look at that, how I am doing the same question with this. Same question I am taking. Evaluate integral over c 2 e power z. From girl side, somebody can take the attendance. Send it to me. Please, Kulsum Fatima, I'll remove from the class. क्लास चल रहा है, सब कर दो. Z plus 1 whole to the power of 3 dz, where c such that z minus 1 is equal to 3. ठीक है, ये क्वेश्चन में फिगर में ड्रॉ नहीं करा था. ये क्वेश्चन में मैं पर्टिकुलरली आपको फिगर ड्रॉ करके भी बताऊं. Actually, common figure for both of these questions. Common figure is this. Actually, this is your circle. Okay. Now you see in this circle, your center is if you take center is what do you say? Center is 1, 0 and radius is 3 units. 1, 0 is the center and radius is 3 units. Okay. तो बेटर आपको और एग्जैक्टली अच्छे से मैं आपको वो 1, 0 सेंटर ही बता दूं. इट्स बेटर. This is y-axis. This is taken as x-axis. So 1, 0 center, how it will be the circle? I'll show you that. 1, 0 means somewhere here it is coming. 1, 0 radius 3 unit. 1 unit. ये हो गया आपका 2 unit. ये हो गया आपका 3 unit. यहाँ से 1 unit. This is 2 unit and this is 3 unit. This is 1, 2, somewhere here. 2 unit. So we have to draw the circle like that. ये आपका परफेक्ट सर्कल बन गया. देखिए सेंटर इसका 1 unit, 2 unit, center is this one and radius is 3. So now you see this point 1, 1 should lie inside the circle. If the points are lies inside the circle, then only we can solve it. Otherwise, we need not to solve it. That has become 0 by Cauchy's theorem. Now here you can say solution में z is equal to -1 is a pole. Z is equal to -1 is a pole of order m. Of order, what is m? M is 3 here. Order 3 we write. Here also z is equal to -1. We can say it is a singular point. यहाँ पर इसको बोलेंगे Cauchy's integral formula. This is called a singular point. In Cauchy's residue theorem, this is called a pole. Z is equal to -1 is a pole of order 3. Now we have to find out multiple pole formula. This is the formula. Residue at z naught. Z naught value is -1. Limit z tends to z naught is -1. 1 by m value is 3. 3 minus 1 factorial d power 3 minus 1 is 2. Like that we have to apply. I'm applying that. Okay, see here. Residue at -1 is equals to, okay, according to the formula, 1 by 3 minus 1 is 2 factorial into, yes, come on, tell me, d power 3 minus 1 is 2 by dz power 3 minus 1 is 2. Okay, limit also will come here. Limit z tends to -1. D power 2 by dz power 2 of z minus into minus plus whole to the power of m value is 3 into f of z. If you continue this, 1 by 2 into limit z tending to -1 d square by dz square of z plus 1 whole to the power of 3 into f of z value. This our entire value is called f of z here. 2 e to the power of z by z plus 1 whole 2. Now you see these two are cancelled. Now we have to differentiate 2 e power z 2 times. We'll get the same answer. Limit z tending to -1. If you twice with derivative, take the derivative, we get the same answer. 2 e power z only, and apply the limit. We get our answer is 1 by 2 into 2 into e to the power of limit z becomes 3 to the power of -1. These two are cancelled. Answer is 1 by e. Now we write it here by Cauchy's residue theorem. By Cauchy's residue, by Cauchy's residue theorem. By Cauchy's residue theorem. What's the formula? Integral over c f of z dz is equal to 2 pi I into sum of residue. 2 pi I into sum of residue, but we are getting only one residue. Okay, only one residue, that is -1 should lie inside the circle. So residue, here we write it as residue at -1. So the answer is, so if you simplify 2 pi I into residue at -1, answer is what we are getting, 1 by e. Look at that, answer is 2 pi I into 1 by e, 2 pi I into 1 by e. So इसका मतलब है finally conclusion is you can either apply Cauchy's residue theorem or you can apply Cauchy's integral formula. You will get your answer will be same, but my suggestion is always apply Cauchy's residue theorem only. Cauchy's residue theorem is very important. Completely 5th unit is depending upon the Cauchy's residue theorem. Anyone want to ask anything? Jazi, are you taking the class? Sorry, attendance.
सेंड कर दिए सर आप।
Okay, right. So, समझ में आई क्लास? ओके